Okay. Oh, it's on that canvas. That's all right. We'll try that. Maybe it'll work. Okay. So phosphorus 31 would go up there, the atomic number 15. And 31 here should be our protons plus our neutrons. And this is an ion. So we know if this is an ion, the protons are not going to equal the electrons, right? So calculate the number of electrons. So we know that we have 15 positive protons. How many negative electrons to result in a -3 charge left over? And we would have to have 18 electrons, right? 18 negative electrons. Okay. Well, that was something we worked on last time, where we worked on mass number, protons, neutrons, and electrons. We completed this table, right? Okay. So now let's continue on. And I need to show you. So we're talking about isotopes right now. What are isotopes again? Atoms of the same element, different numbers of neutrons. Therefore, you get a different mass number, correct? So the first two examples on our chart, these are isotopes. So let's look at isotopes that are naturally found in nature. And I got to make sure I'm on this screen now. Right here. Okay. Now, this is the abundance of naturally occurring isotopes in nature. So, if we take lithium, let me see if I can make this bigger. Yes. There are 2 lithiums found in nature, lithium-6, lithium-7. This is the percent abundance, and this is the mass of lithium-6. This is the mass of lithium-7. Now, some elements, they don't have any naturally occurring isotopes. Beryllium, 100% of the beryllium found in nature is beryllium-9. Boron here, 2 isotopes, nitrogen, oxygen, and so on. 100% of the fluorine found in nature, fluorine-19. Neon has 3 isotopes. Sodium, 100% of the sodium is sodium-23. Now, the big one that we talked about was to make the bomb, we needed uranium. And let's see if I can get to that. Yeah, here we go. So here's where the uranium number comes from. There are 3 isotopes. And we needed uranium-235, right? Which is only 0.72% of the uranium. So the question is, on our periodic table, we have the atomic weights. So look on your periodic table for a key, and on the periodic table, our atomic weights, look in the bottom left, atomic weight in red. So down on the left key, here's our atomic weights in red. Now, for sodium, notice not a problem. Sodium is 22.9898. So if I go back to my chart, sodium, right here, sodium, 22.9898, no problem. But magnesium, here's magnesium. There's 3 isotopes found in nature. What number do you put on the periodic table? Well, you put a weighted average on there. So if 78.99% of the magnesium found in nature is magnesium 24, 10% is magnesium 25, and 11.1% is magnesium 26. We need to figure out a weighted average. So again, you only have to do that if there's more than one isotope found in nature. Aluminum, 26.98. So if we look on the periodic table, aluminum is going to be 26.98. So let's calculate this magnesium out. So I've got an example here. And this really is no different than, let's say you've got 10%, don't write this down. 10% of your final grade is homework. Let's say 20% is lab, and that means 70% were tests. This is not it. Do not write this down because I don't have OWL in there. Let's say that your homework average is 90, your lab average is 80, and your test average is 100. What's the weighted average out of all that? What is 10% of 90? 9, right? That would be 0.1 times 90 is 9. What's 20% of 80? That would be 0.2 times 80 is 16, correct? And 70% of 100 would be 70, and we'd add that all up, and your weighted average score would be 95, right? But it's not any of those 3. It's a weighted average. And your final grade is like that. It's got OWL in the quizzes and the tests in it, everything. Not lab. Okay. So let's do the weighted average here for this example. So a sample of magnesium is found to contain 78.99% magnesium 24 with this mass. 10% magnesium 25 with this mass, and 11.01% magnesium 26 with this mass. Okay. Verify the atomic weight of magnesium atoms as on the periodic table. So we would do a weighted average. So we're going to take this percent, change it to a decimal. So we get 0.7899. We're going to multiply that by our mass of 23.9850. AMU. Plus, now I added them up here, correct? I added them up. So we're going to add them up here. We're going to put this on one line. 10% would be 0.1000. The mass is 24.9858 plus 11.01% would be 0.1101 times 25.9826. So you don't need any parentheses in your calculator. Do not do any parentheses in your calculator. Grab your calculator, run that through. Remember, blood flows better to the brain when using your calculator. Don't be brain dead. Run that through your calculator. All in one line. Multiply plus your calculator will do the order of operations correctly. You don't need any parentheses. Multiply plus, multiply plus, multiply equals. And we get 24.305. Yes? No? Yes? Okay. So we get 24.305 AMU for atomic mass unit. Therefore, you look at our periodic table for magnesium. $24.305. Weighted average, right? This is the weighted average. So all of the elements on here, if they have isotopes that are found in nature, what is on the periodic table is a weighted average. This owl question makes me really mad. It infuriates me, to tell you the truth. Maybe I should yank this. Ugly owl question, chapter 2, part 1. The element antimony has an atomic weight of 122. Where's the decimal places? Just 122. Okay. It consists of two stable isotopes, antimony 121 and 123. The isotope antimony 121 has a mass of 121 AMU and a percent abundance of 57.3. The isotope antimony 123 has a percent natural abundance of 42.8. What is the mass of antimony 123? So let's decipher this. This is the result that we would have on our periodic table, 122. Why they skipped all the decimals is beyond me. It's kind of infuriating, which is why when I see stuff I don't like, ugly owl comes on here. Okay, so this is all right. This part right here, that would be, I'll put it right here, 0.573 times 121. Now it's 121 and it's 123. The percent abundance is 42.8 for 123. But this is what we're trying to calculate, X. $123, but X AMUs. That is equal to 122. This would make so much more sense if it had some decimal places in here and they used better numbers. So if we have to solve this for X, let's do that. We have 122 here. This result is going to be subtracted from both sides, right? So let me do a little bit more than I did last time. 0.573 times 121. Okay. So we'll solve it right here. So this gets us 69.33 AMU plus 0.428x equals 122. we'll subtract 69.333 from both sides. Right? So we would end up with 0.428x equals 122. I know I'm going to have AMU. I'm going to drop my units for right now. Minus 69.333. 0.428x equals 52.667. We have to divide both sides by 0.428, right? To get x. And we get 123. It's a confusing question. So we get 123. So that's what that OWL question is looking for. So I'm sure you're going to calculate some weighted averages like this, but then it's going to actually give you the weighted average and have it calculate this. Or it could have you calculate a percent as well. Okay. Let's go to the next page. So on the next page, we've got some information about the periodic table here. So 1870, Dmitry Mendeleev was credited with creating the first periodic table of the elements. The periodic law states the properties of an element of the elements are a periodic function of their atomic numbers. The table has 7 horizontal rows called periods. And 18 vertical columns. Now, be careful with this. So we've got 7 periods here. We've got 18 vertical columns. My vertical columns I like to do is I just keep everything. We'll look at it on this table because you can't trust the A and the B and the A to be the same. So be careful in OWL. Let's look at this table. It actually matches. But 18 vertical columns. Here's column 1, column 2, but it could also be 1A, 2A. I'm going to use the 18 numbers, 1 through 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It is much clearer because some textbooks will call this an A or something, but just 1 through 18. Okay, these are 18 groups then, or families. Group 1 elements are referred to as the alkali metals. So we know group 1, alkali metals, group 1. Group 2, alkaline earth metals. Group 17, halogens. And group 18, of course, noble gases. Those are the main ones: alkali metals, alkaline earth metals, halogens, noble gases. Then specifically here, we've got nonmetals. We've got metalloids. And we've got the transition metals in the middle here. Now, take out your periodic table. If you take out your periodic table, let's put this staircase line in. Put this staircase line in on your table. So go between boron and aluminum. Ends right here. This matches what your textbook does. The ones that border this staircase line are your metalloids. They're not really metals. They're not non-metals. They're kind of in between. But aluminum is not counted. So put in a staircase line right there. That would match up what we have in green. And then notice aluminum is right here, not counted. So this is the line. Okay, let's see the next page. So you're going to get some alt questions like this, perhaps. Noble gas, same period as germanium. Noble gas, what group do you have to be in? Group 18, yes? Noble gases, got to be in group 18, same period as germanium. And germanium is in what period? So the noble gas in 18, germanium's right here. So 18, same row, we're going to end up right here, krypton, yes? Okay. And the period was 4. Alkaline earth metal. Alkaline earth metal is in group 2, same period as selenium. Okay. Alkaline earth metal. That's in group 2. Alkaline earth metal. Same period as selenium, which is right here. So we're going to go across. And we're going to end up with calcium. Halogen, group 17, same period as lithium. The halogen in the same period as lithium is fluorine. Okay. Alkali metal, 11 protons. What's the alkali metal with 11 protons? Group 1 sodium, yes. And mass number would be 23 and 11. The noble gas, 75 neutrons, 54 electrons. Noble gas, 54 electrons. Xenon. $33 protons. Oops, I better put this. Okay, we got 75 neutrons, 54 electrons, which would be 54 protons. So this would be 119, yes. 75, 54. 129. 129. Rewrite this. 129, 54. $33 protons, 40 neutrons, 33 protons gets us what? Atomic number 33 is arsenic. Mass number would be 73. Alkaline earth metal, 88 electrons. 88 electrons. This has to be group 2. What's that get us? Radium, yes? 88 and let's see, 88 and 138 is going to give us what, 226? 226. Okay. Ionic versus molecular. A compound that contains ions and is held together by ionic bonds is called an ionic compound. These compounds usually contain a metal ion. An example is table salt that has the formula NaCl. For ions, see the pink sheet, which we looked at before, yes? I need to get this. Some of you need one of these, yes? No? Yes? Okay. Everything on this side that we looked at last time is a charge. These are ions, yes? Okay. When atoms share rather than transfer, gain or lose electrons, you form a covalent compound that contains covalent bonds. Carbon dioxide is an example of with the formula CO2. So, covalent bonds, think of this. And what do you end up with? You have two non-metals bonded. Two non-metals. Carbon dioxide, carbon monoxide. An ionic compound starts with a metal ion. Okay. Al does a little bit. Now, these are molecules here, molecular formulas. Notice this is all nonmetals. So this and this would be covalent. All nonmetals. Now, Al has you do a little bit of these, putting these together. Here's my carbon with 3 hydrogens attached, right? My carbon with 3 hydrogens attached. Here's my carbon here that has hydrogen, and then it has the OH attached here. So there's the molecular formula, and then there's a condensed formula, structural formula. This actually seems, this switched around. And then we have a model here. Now, what we did last time was we did this first page. And on this first page here, metal, 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 metal. Ionic compound. These last two, non-metal, 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 covalent. So here we have covalent compounds for these last two here. Hopefully you finished page 1. The answers are in Canvas. There is a page that I've scanned with all these answers. Okay. Now let's do this. These ions here, we need to take a highlighter. Grab your pink sheet, take a highlighter, whatever it is. These are the common ones that we are going to highlight right now. So grab your pink sheet, highlighter, something. Because this matches what is going to be on the test. So hopefully we will use these enough where you're just going to memorize them, but otherwise you want to remember these. I don't know if you got to make some note cards, but you can't use the pink sheet on the test. I used to do it and I got chastised. So let's highlight these. You got acetate, ammonium, bicarbonate, bisulfate. This is also, you can write it in, hydrogen sulfate. Same thing, hydrogen sulfate, bisulfate. Then carbonate, chlorate, chlorite, chromate. Then we should have, so we've got these 4. Okay. Cyanide, dichromate, dihydrogen phosphate. Okay, I'm going to go to the middle column. We're at hydroxide hypochlorite in the middle. Hydroxide hypochlorite. Let's go back to this. We can call this one hydrogen carbonate. All right, let's continue down the middle then. Down here, we should have monohydrogen phosphate, nitrate, nitrite. Get rid of nickel 1, get rid of nickel 1. Or excuse me, nitrogen. All right, oxalate, perchlorate, permanganate, and then phosphate. Oxalate, perchlorate, permanganate, phosphate. And then we have sulfate, sulfite to finish this off. Sulfate, sulfite. Okay. So we're going to go back to writing formulas for compounds a little bit. Then I'll have you do a little bit here as well. This is a question similar to our homework. So we have C2H5NO. And how many carbons do we have here? We have 1, 2, 3 carbons. Yes? 3 carbons. So we know number, this one's junk. We have 1, 2, 3, 4, 5, 6, 7 hydrogen. So it looks like we got the answer already, right? 7 hydrogens, and we have 2 oxygen. And we have a nitrogen. So you should be able to match that up. I'll have you do a few of these problems. Now, this is a covalent compound, all nonmetals. So what do we get? C, it's got to be this one. Huh? All right. So we worked ahead a little bit. In ordinary chemical reactions, the nucleus of each atom, and thus the identity of the element, remains unchanged. Electrons, however, can be added to atoms by transfer from other atoms, lost by transfer to other atoms, or shared with other atoms. During the formation of some compounds, atoms gain or lose electrons and form electrically charged particles called ions. This is an example of that. This is a sodium atom. What's the definition if you have a neutral atom? Protons have to equal the electrons, right? That is the definition of an atom. It does not have a charge. We can put a 0 right there. No charged ion. How do you form a sodium ion? In this case, we have 11 protons, 11 electrons, right? This is an atom. 11 positive protons, 11 negative electrons. Sodium ion. We still have 11 protons. But now we only have 10 electrons, right? 10 electrons. Where did that electron go? To another element that wants it. What's an element that wants it? Chlorine, right? So we can come up with the formula NaCl, right? Positive 1 ion by losing an electron, negative 1 ion by gaining an electron. Sodium chloride. And notice the radius of the ion is less than the atom. Negatively charged ions, anions. When atoms of metal elements form ions, they generally lose enough electrons to give them the same number of electrons as the atom of the previous noble gas in the periodic table. We'll talk about that towards the end. These charged ions, cations, positively charged cations. When you do the test, you're going to be given a periodic table. You need to know that everything in group 1 of the periodic table is a plus charge. Everything in group 2 of the periodic table, plus 2 charge. These transition metals can have more than one charge. If they have more than one charge, it's going to be represented by Roman numerals, right? You need to know all of the halogens here, -1. Everything here, -2. Aluminum's always +3. So you're going to be given a blank, not a blank. You're going to be given a periodic table, but realize that you can look where they are to get the charges of the ions, right? Okay, I'm going to come back to this page later. I want to get us going here, writing formulas of compounds and show you some things so you can poke away more at OWL. So we're going to page 2. So on page 2, now, these top 8, I made them no-brainer. And the reason I made them no-brainer is because the positive ion only has one possible positive charge. Ag is silver. Li is lithium. Sc scandium, and Mg magnesium. So on the left, positive, 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 right? Positive ion. I didn't put the correct charge in, but I guess I can put them in. +1, +1, +3, and +2. For our negative ion, P, if it's a neutral atom or a positive ion, would be called phosphorus, but you know it's negative, correct? So it's not going to be called phosphorus. It is going to be phosphide, right? IDE. So this is going to be lithium, not sulfur. This is going to be lithium sulfide. This is going to be scandium oxide, magnesium nitride, right? All of them end IDE. Now, the reason I said these top 8, I'm not going to do the next one. These positive ions, they only have one possible positive charge. So we do not need Roman numerals. You are not going to add Roman numerals. Then students get Roman numeral happy. And pretty soon for NaCl, this is +1 and -1. What's the only charge sodium can ever be? +1. So you just would write down sodium chloride. You would never write down this. We don't need the Roman numeral 1. It's always 1. That's the only thing it can be. So you would never write down Roman numerals. So, but what do we got to do now is we got to figure out Roman numerals. Okay. So how do you figure out Roman numerals? There isn't more than one negative charge. -1. Notice chlorine. Chlorine is +1, +3, +5, +7, -1, +1, +5, -1, +2, +4, +6, -2. Now, what did I cross out here on nitrogen? What's on your table? Another was that a -2 or something? I don't know where the heck. Cross that out. That's a bunch of crap. I haven't seen that until now. That's just a bunch of crap. Cross out that -2. Okay. So if there's only one negative possibility, it allows us to calculate the positive. So here we have manganese oxide. What's the charge of oxide? Always, always, always oxide. Right? This column. -1, oxide is -2. Well, oxide is -2. Manganese, look at this. Manganese can be 2, 3, 4, 6, 7. Which manganese do we have? In this case, we know it has to equal 0. So this is manganese 2, correct? So we know we have manganese 2 oxide. We have MnOO. We have 2 oxides. What's the charge of my oxide? -2, -2. What's the charge of my manganese this time? 4, right? Here's my manganese 4 oxide. Again, I got to get 0. So this manganese 4, 5 minus 1 for a Roman numeral. What's my charge of this manganese? 6, right? This has got to be manganese 6. Chromium sulfide. Chromium sulfide. What's the charge of sulfide? Oxidation state, I should say, sulfide. -2 column, yes. Same as oxide, -2, right there it is, -2. So -2, -2, -2, plus 6, yes? Mn4C7. What's the charge of carbide? What's the charge of carbide? -4? Okay. -4. I don't want to write. I guess I could write them all out, huh? Oh, man, I guess. Mn, we would need 4 of these, right? 4 manganese. Slam down 7 carbides. Right? Let's do a little multiplication, though. -4, and if you got 7 of them, -28, right? -28. You know you're going to get a positive 28 out of these 4 manganese. What charge or oxidation state are these manganese then? These are 7s, right? Manganese 7 in order to get 28. Okay. Let's go down to 15. We have tungsten sulfate. Tungsten sulfate. Here's what we have. We're going to write these compounds yet before we leave. Sulfate. What is the oxidation state or charge for these 3 sulfates? What's the charge of sulfate? And you can look on the pink sheet. It should be highlighted. -2, right? Sulfates are -2. So -2, -2, -2. What's my tungstens have to be? +3s for these, yes? Now you might say, well, can tungsten be a +3? Well, let's double check. And tungsten can be all of these. 2, 3, 4, 5, 6. So it's a tungsten 3. So we have tungsten 3 sulfate. Vanadium carbonate. So carbonate should be a common one. What's the charge or oxidation state for carbonate? Look on your pink sheet, should be highlighted. -2. So -2, -2. What's my vanadium? +4. Manganese nitrate. Nitrate should be highlighted for sure. Manganese nitrate. What's the charge of a nitrate? -1. We've got 7 of them. That's -7, yes? And if we only have 1 manganese, it has to be a 7. Has to be a 7. We have gold chromate. So we have AU, CrO4, 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 right? The oxidation state of chromate is -2, -2, -2. What are my golds? These are 3s, right? 3s, gold 3. Okay. But you're only going to put in Roman numerals if they have more than one possible positive charge. Go to the next page. I'm going to flip this over just to show you this. In fact, let's put it on the back. This is worth putting on the back. Flip this over. So however you have it, if you're using good notes, just go to the end. Now, there is perchlorate, there is chlorate, there's chlorite, and there's hypochlorite. I think we got them all. Yes. All 4 of those are highlighted. Right? Perchlorate, chlorate, chlorite, hypochlorite. These are polyatomic ions. What's the definition of a polyatomic ion? A group of ions that stay bonded together, that have an overall charge or oxidation state. Both of these are ions that stay bonded together. If they're ions, they have individual charges, correct? What's the charge of my oxides in all of these? Because oxide doesn't change. What's the charge of my oxides? Oxide's always -2, yes? -2. What's different in all of these is the charge on the chlorines. But they stay together. What's the charge of this chlorine? All right, start doing mental math. You have 4 oxides at -2 each. -8, yes? -8. What positive number -8 leaves us a -1? +7, yes? We have 3 oxides again. What's the charge of oxide? -2. -2 times 3, -6, yes? -6 here. What positive charge -6 leaves us a -1? +5, right? Two oxides, -2 each, -4. What positive number -4 leaves us a -1? +3. And this oxide's -2. What's the chlorine's charge? +1, right? The oxide charge does not change, but you just have different chlorines. And if we look at our periodic table, we got 7, we got 1, 3, 5, 7, and we have 1, 3, 5, 7 if it wants to focus, and a -1 if it's negative. So when you see polyatomic ions, they are made up of 2 or more ions, but they stay bonded together, so you treat them as one unit. So let's go to page 3. On page 3. So we have this compound, sodium hexacyanoferrate 2. You could sound that out. It looks worse than it is. Hexacyanoferrate, right? So let's do the same thing. We have sodium. What's the charge of sodium? Always, 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 forever and ever? +1, right? This is a freak. It's got a Roman numeral here on the negative charge. So you'd have to look this up on your pink sheet. Hexacyanoferrate 2. FeCN6 -4. How many sodiums do I need? I need 4 sodiums, right? So it'd be this. Carbon dioxide, carbon dioxide. Carbon should have a Roman numeral, it does not. Dioxide, you're going to use the prefixes for this. So carbon dioxide is going to be CO2, right? CO2, we're not looking up charges. Now, to help you out with OWL, if you get ahead of an OWL, let me show you this. If we name this compound using prefixes, this is going to be diphosphorus. This'll clear up the OWL a little bit. Diphosphorus, no problem, right? Okay. What is the O? Oxide, correct. And the prefix for 5 is penta. Now be careful of that. This is what's going to clear it up. I put this A in parentheses. They never put double vowels together. So it's not going to be pentaoxide because you have an A and an O together. It's going to be pentoxide. Okay. So be aware, OWL does have some like this. So this would be diphosphorus pentoxide, not the A, not pentaoxide. Pentoxide. All right, let's do number 3. Ca. Calcium Ca, what charge? +2, it's in group 2. Sulfate. SO4 -2. So +2, -2, we're done, correct? All right, now. Magnesium chloride. Magnesium is Mg. What oxidation state? +2. Chloride. ClO2 -1. We need another chloride, right? So we have another chloride. What are we going to do with the chloride? We're going to put it in parentheses and we would write it like this. We have 2 chlorides. Do not go parenthesis crazy now. When I show, so all of a sudden they go crazy. They lose their minds. And pretty soon the formula for water looks like this. NaCl for salt looks like this. They go parenthesis crazy. They lose their minds. Do not put that's not going to do us any good, right? You are only going to use parentheses when you need more than one polyatomic ion. Don't go parenthesis crazy. Number 6, I want to do because students typically do not put a parenthesis in and they need to. This iron 3. Hydroxide is OH -1. How many hydroxides do I need? I need 3 of these hydroxides, right? So when I'm all done, that gets me 0. I should have FeOH3. There has to be a 3 there. I want you to go through page 4 on this. No, I don't. Finish this page. Finish through page 3. Look in Canvas. There is a scan of all the answers. In Canvas, there is a scan of all the answers. Look to make sure you're not going parenthesis crazy. And don't think you just have them right. Look, they should match exactly what I have. And it's those little things that if you don't look to make sure they match, then you end up with stuff wrong. On this quiz, I want you to do on this quiz, one through 16. Skip 3, 4, 12. 1 through 16, skip 3, 4, 12. On the other quiz, the other quiz is still 1 through 13. Actually, 1 through 12 we had before. Let's see, is 13 on there? Yeah, you should be able to do 1 through 13 now. All of these. On this quiz, 1 through 13. Now, we did formulas of compounds. This wasn't supposed to be up there. I don't know if it's gonna work. Ah, it's good. It might work. But the formulas of compounds are the exchange of electrons, yes? Some electrons are fastly exchanged, some are slow. Like if you buy a new car, eventually it's rusted out, that takes a while, but that would be slow, yes? See if I can make this up really slowly. And some will go this fast if this works. If this works, I gotta get taller. Ah, without falling off here. Whoa, 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 whoa. Ah! Wait a minute. Give me 1 second. I got it. Who's got a book? Wait, hold on, 1 second. 1 second. 1 second. I feel bad about this now. I'm gonna get this. I need an opportunity to fight color. Come on, come on, come on. And some electrons exchange really fast. All right, we'll see you guys on Thursday.